Hello everyone, it's Dmitry Anoshan and we're still on the Model 0. And today I want to talk about very important and complicated topic. It doesn't matter where you're now, you might be very new or you might be experienced, but you probably heard about Python. The Python is #1 language for data jobs, for data engineering, for data analytics, even for machine learning and generative AI. So Python is very popular. So no matter what, of course you need to learn SQL and know the SQL very well. But also you need to know Python. But to learn the Python from the start is pretty big and complicated topic. That's why I want to talk with you and tell you a bit about how you can start to learn Python, how you can practice this, what's the key use cases for the data jobs, and share a bit of my personal experience how I learned Python. So, because you're on the journey to get the job in the data field, and if you already experienced with the Python, you probably can skip it. But if you're just starting and before you used to work with maybe a bit of SQL, a bit of BI applications, or even just coming from another industry, it doesn't really matter. But this video definitely help you to get the key ideas about the Python, why you need to learn it, what you need to learn, and where to start. So I would like to start from the quote. The most important skill for a computer scientist is the problem solving. The problem solving means the ability to formulate the problem, think creatively about solutions, and express a solution clearly and accurately. So the problem solving is the most important. It's not only for computer scientists, but it's the same important for data roles. So you might work as a data engineer, data analyst, data science, machine learning. You always focus on the problem first. Obviously, this problem should come from the business, and you will learn more about this in the Model 1. Already maybe you check the Model 1, doesn't matter. But the problem is very important. We shouldn't just spend timing to write the code, build pipelines, analyze the data just because you like it. We really want to focus on the business problem. We really want to focus on how our skills can add the value for the organization, for the business, because most of the business, especially in the area where we are working, is really for profit. So that's why we really focus on the high salary. That's why we want to solve high bid problems. That's why always think about the problem, what problem you want to solve. And this is just a reminder for us. Yeah, couple screenshots why the Python. They might be a bit outdated. For now, you can check the Python even more popular, but it's very popular. You can use Python for anything, for data analytics, for even today I was preparing for the Model 5, a bit of a cloud computing and infrastructure as a code, and there are lots of packages that can support cloud infrastructure as a code. So that's why you can literally solve any problem with the Python. Of course, it has own downsides. One of them is the performance. And if you consider to build some kind of production-ready application, then Python might be not the best. And especially if you think about really large applications, and think about anything for small prototype and the small application, it's fine. But something worldwide ready for millions of consumers, usually it's not the Python. But anyway, I don't want to go in details about when Python is popular, when it's not. Just take it as a granted. Python is #1 computing language. And of course, nowadays, with help of AI, it doesn't really matter what kind of language you use. You can equally be expert with Rust and Go, and you can today using your AI IDE to generate pipelines in Python, and tomorrow you can switch to C++ and Rust. Of course, to do it in production is a very different topic. But assuming you join the company who doesn't really use Python, they use the Scala. And you need to contribute to the Scala pipelines and Scala transformations on Spark. Obviously, without knowledge of Scala, you couldn't be efficient. It was in the past. Nowadays, you can use Cursor, Cloud Code. They can help you to analyze the repo, and you can instantly contribute to the repo with really good quality of the code. Just focus on the small area first. You don't want to change a lot of things. And in the next video, by the way, we'll look to IDEs and AI assistants like Cursor, Claude Code, and some others. And there are some Python alternatives. So it could be Scala, like especially if we talk about big data, Spark, Hadoop, the Scala is a very popular choice. Rust is really high performance and efficient language, but the community for data engineering and data is not that big. The R was very popular before the Python. And I remember the time around 2012, I was thinking, do I need to really invest time in R or Python? Python looked for me more like engineering language versus R more like science language. And that time, if you would go to Coursera to learn a bit about the sexiest jobs of 21st century data scientists, all the models, all the lections will be in R. That's why obviously everyone starts from R. But nowadays, there are some companies who still has legacy code, the pipelines written in R. Or there are some connectors connecting to Google Analytics, Salesforce written in R. So R is still programming language and you can achieve a lot with this. But for me, and again, take it as a granted, R is not a good choice nowadays. Just focus on the Python first. And C++ in other language that also popular, and some real-time application might be written in C++. I know the Spark supports C++, or maybe it's C#, I forgot, but there are more languages available. It's the Go and so on. So we don't need to think about alternatives. Just think about the Python is the language that you definitely need in the data analytics space. But it's not really mandatory to get the first job. And you will learn more about this in the future models. The way how to learn Python, because obviously you can go to the trainings and workshops to practice with the Python, but unfortunately it's very fast-paced, either video or workshops, it's not enough time to digest and understand. So my advice to you, the best way to learn Python is through the reading, because the reading, you start reading in your own pace, you can do exercise, you can return back if you want, you can have conspects on what you learn, and you can repeat. One technique really helped me in the past. I can write down scripts in Python and just learn them by heart, trying to understand what they mean. Then I use commute, then I go outside, I can open my notes and check them. There are two books I would like to share with you, and they're really good, because I used to like to read a lot of books about Python and other technology, and I used to have O'Reilly subscription, and I really like O'Reilly books. The first book I would like to highlight is Think Python. This actually is a free book. You can find it for free and download from the author page. So the Think Python is really simple and is a good starting point for you to learn the Python. Another one, the Python Crash Course, also very simple, but this book consists from two parts. The first one is similar to the Think Python. They talk about functions, classes, variables, data types, and so on and so on. But the second part of the book, you actually building some real-world Python applications. You build the website, I think using Django. You build the game that has a lot of files and models working together. You do some data analytics solution, and so on. So it's a really good example. Then you can apply the Python knowledge that you learn to actually build something end-to-end. So I highly recommend this book. And of course, there are more books about the Python. You don't need many books. Well, a friend of mine gave me really good advice. If you want to learn something, you just need to read at least 3 books from this topic. So my advice to you, don't waste your time on the video tutorials and everything else. Just get 3 books on the Python. You can go to Amazon, check the best books based on the review, and just get them. Those are my books that I recommend to you. And if you don't know what to start, you can start either Think Python, it's a very small book, or the Python Crash Course. So it's a very good book. And they're very easy reading. So now I want to talk a bit about key topics for the Python. So the Python is a programming language. And obviously then you work with in the data space as data engineer, data analyst, you don't really create the tools. And very often use the tools that are ready for you. And you might need to do a bit of ad hoc requests using Python, but you always have the alternative, this SQL. Or you can contribute to the Python code in case, for example, using Airflow for your orchestration, or maybe another tool like Apache Superset that also support the Python. Or maybe you just need to contribute in the Spark and you need to know the PySpark. So the key topics in the Python that are applicable for the data roles, let's check them out. Data manipulation. So you might use, for example, Pandas library to manipulate the data, review the data, analyze the data. It's more suitable for the data analyst and data scientist role. The data processing, so this is more suitable for data engineers. Database connectivity, again, if you think about building data solution and you need to extract data from API or database, you need to connect. And then you need to process data and write to another database or maybe save in the files. Data validation and quality, because we work with the data, we build the dashboard, so the data quality is very important. Cloud and infrastructure, so you can interact with the cloud, you can interact with the infrastructure using the Python. Data formats and serialization is also very important. Advanced concepts, I will talk more about them, and also I will share a bit of best practices. So I don't want to spend time in this model to actually teach you something. I just want to give you the scope and sharing the approach how you can start to learn the Python. So let's now review some concepts. The core Python fundamentals, things that you need to learn and you need to understand. So variables and data types, data structures, control flow, it's different loops, while loops, if else statement, it's very popular. So functions, it's another thing, it's very popular. List of comprehensions, probably it's more important for the data interview if you have whiteboarding interview, but still good thing. The way how you can build the list with one line of code. Exception handling, this is not very popular, but still a good thing to know. And every time you write the code, it's a kind of like good practice to use them. Models and package, because you can reuse lots of packages that already available for you. You just import them and use. And virtual environments. This is a very important topic to know. So I would say that the most important things for you to know and understand is the virtual environments, model or the packages, functions, control flow, data structures, variables, and data types. So those just 5 things that you have to know really well and understand. And you can get this information very fast from the books, from the videos. And if you don't understand, just make the break and try to learn and understand really well before going deeper into it. So let's stop on the data manipulations. So for data manipulation, one of the most popular package is the Pandas. The Pandas let you work with data frames. So data frames are kind of like abstractions of your data. Imagine you have CSV file, you want to process it and read it and maybe create some kind of analysis. So you would use the Pandas as a library, you will import Pandas, and then you will read the file and create data frame. So data frame is abstraction. If you know SQL and database, you can think about this as a table in the database. And then you can start, you apply the different methods. You can read, you can group, merge, pivot, and so on and so on. To do basically the same things that you can do in spreadsheets. But the Pandas has lots of downsides. It's good for your local notebook environment that you can analyze the files, but it's not very suitable for the production-ready pipelines. So that's why it's not a good choice for data engineers. NumPy is another thing, how you can work with the data, you can create arrays and do mathematical operations, more like for data scientists. Polars, it's the faster alternative for Pandas, and Pydantic is another data format. Or nowadays, you can just use DuckDB. It's extremely fast database that I reviewed in the Model 2, and we have some projects. You can definitely check it out. And nowadays, you can solve pretty any problem with the SQL without going deep into the Python. You can think about Python, assuming you join the organization, they already use the Python. And this is the case, and you need actually the skills to understand what they build, because you probably go into repo and see what kind of code they use, what kind of transformations they have, because in the repos you can find the Dockers. We already covered in the previous models. You can see some different file types examples. You can see the Python files, Python transformations, and so on and so on. So that's why this is definitely helpful to know more about each of the formats available in the type of the repos or use cases. The data processing, we can think about PySpark is number one, but not everyone using Spark nowadays, because for the Spark is probably either open source Apache Spark or the Databricks, and Databricks support the SQL and Apache Spark supports Spark SQL, so you can still solve all this problem and process all the data just using the SQL. But the PySpark is very popular. The Dask is parallel computing for larger than memory data sets, but I never use it. So it's just good to know that it's there, and maybe some organizations might use it, but I personally never used it in 15 years. Apache Airflow, this one is extremely popular, and we will cover it in the Model 4. This is framework for running your pipelines to schedule them. It's a kind of like cron scheduler. The cron scheduler is the simple things that you can schedule and automate your jobs in CLI tool on your Linux or Mac OS machine. So the Apache Airflow is a kind of nice UI where you can schedule your pipelines to extract data, transform data, and write data. And we'll talk more about in the Model 4. And to create the job in the Apache Airflow, you need to know the Python. But it's more like template framework. So data engineers might set up Airflow, and then you just copy-paste the job and changing some of the parameters. So again, you don't need really knowing Python well, but you still need to understand the code, like to read the functions, to read the variables, and just to understand what's happening in the job. The database connectivity is also important topic, but again, it depends on you, because if you will use Apache Airflow to extract data from Postgres database in backend, and you just rely on the Python, then you of course need SQLAlchemy or psycopg libraries to connect the Postgres. But you might use Fivetran. Again, we'll cover this tool in the Model 4 about ETL tools. So Fivetran is a really nice UI tool, no code at all. Or you might use open source alternative like Arbeit. But you still need to know that there are a couple libraries for database connectivity in case you need to do this. And we will do some exercise to using this. Even in the Model 2, we'll have example with the Postgres, and you need to write the Python code or generate it with AI to take CSV files and load them inside database. Data validation and quality is an important topic, but depends on the tooling, because data jobs is about tooling, not about like just raw Python. Of course, you can use the raw Python, but unfortunately or fortunately, it's not scalable. Imagine you have a team of 10 people, and if everyone writing the Python code in their own flavor, their own practice, it's very hard to actually create the production grade data engineering solutions, because as soon as like experienced engineers drop the company, you might end up with lots of legacy code. That's not that good. So, but still, let's cover some things related to the Python and data validation and quality. So Pydantic, Great Expectations, Pandera, unit testings, especially pytest, and I mentioned here DBX is a Databricks framework. They're also about data quality things and data validations related to the Python. And there is another concept like test-driven development. Then you, for example, want to analyze the data, you create the function, but before you create the function, you create the unit test that will cover this function. And it's another topic more like from advanced use cases. Cloud infrastructure, for example, the most popular Python library for AWS is the Boto3. So it's kind of like AWS SDK that you can use if you want, for example, trigger some jobs in AWS or create some resource or do something in AWS. You can use just the Boto3. It's very popular. The same alternative for Google Cloud Storage, Azure Storage Blob, for the Docker, and especially very popular use case for API request. Probably because there are lots of data sources coming from APIs, and if you don't have connectors for API like Fivetran and Arbeit, or maybe using another open source tools like DLT. But to using DLT, again, you need the Python. You can just use the request library from Python that's specifically to connect the API endpoint and get the data in JSON format, and then you need to process and manipulate this data to save it in database or in files. And in case you want to save this in database, you need to know a package for connection for database. That's why it's all kind of like connected together. And the best thing to learn it, after, of course, you're reading those books and get some basic knowledge, then you can do some pet projects to know those use cases. Because for the data engineering, data analytics, I would highlight 5-6 use cases, and you need just to build 5-6 pet projects to understand like all possible use cases for the Python. And this will cover, the 20% of knowledge will cover 80% of the use cases for your career. Data formats and serializations, of course, you need to know how to work with different file types like JSON, CSV, Parquet, Avro, and so on. In terms of package managers and environment managers, so there are tools exist that like package managers, they install, update, and manage Python packages and dependencies. Environment managers, on the other hand, create isolated Python environments to avoid dependency conflicts. There is known term like packages hell, the things that you want to avoid, because different packages, they can have conflicts with each other. That's why for every new project, by project I usually mean that you have the repository repo, for example, GitHub repo, and this is your project. And inside you can define environment, use environment manager and package manager to kind of like highlight all the versions of packages you're using, because your goal, if you create some applications or pipelines, that it could be run on another machine or your colleague machine or host in the cloud, or maybe Airflow will run it. That's why you need to reproducible environment. That's why those package environment manager exist. The most popular probably is, in terms of package managers, the most popular is the pip. And nowadays, the alternative is UV. This is Rust-based one. It's very fast and very efficient. The Poetry is another one. It's quite popular for the data teams. For Surfalytics projects, we use the Python in our projects. We usually starting from Poetry or Venv, and you just need to start to get hands-on with those things. And for example, some of them, they can support both, for example, Poetry or UV. It's at the same time as a package manager and environment manager. So you just need to pick one and trying to learn it well. You don't need to actually learn it, just use it several times. Let's talk a bit about advanced concepts. So decorators, one of them. And usually you don't need to create your own decorators. It's usually then use some kind of tools, Datadog or Daxter. They have decorators out of the box to use the functionality of the tool. Generators, context managers, type hints, async await, logging. So I would like to highlight the logging is very important. In case you, for example, building Airflow DAG or your own extraction data transformation job, the logging is very important. That's why you just need to use the logging library, and there are also different flavors of it to actually get, because then your program is run and your data transformation run is kind of black box. The logging gives you visibility to what's happening inside, and in case of any failure, it also will give you information. Or you can think about, you run your pipeline on the cron schedule every day. You won't just log the information and maybe save this information in the database or some kind of tool to be able to analyze it in case you need it. In terms of best practices, really worth to mention style guide, the pip 8, the one, and then you always, if you work with the code, you always need to use Git version control, CI/CD. This is more coming from software engineering world, but this is your advantage. Using software engineering things in the data space, it's actually give you advantage. Yeah, and if you want to be a data engineer, you just have to do this. The sooner you start, the better for you. Environment variables and configuration management. Invariable variables is a very important topic because this is how you can secretly sharing your credentials. Because you don't want to copy paste your password in your tools, in your code or your LLMs. That's why we're using environment variables. And for you to practice, if you want just, you want just practice and see some concepts, the one really good course I found, it calls AWS Python Bootcamp. This is actually have all things you need to know, because if you look to agenda, it has variables, data types, Python packages, functions, arguments, parameters, inputs, loops, if statements, logging, errors and exceptions, persisting data, and also a bit of AWS. This is more like Model 5 about cloud computing, but it's very good because if you will start this bootcamp, they let you use their own IDE in the cloud, but you can use your own IDE, for example, Visual Code, and then you can build all kinds of things. Try the Python, and maybe the very first exercise for the Python will be just this bootcamp, and then you can switch to the books. And after the books, you can again repeat it, because then you will do this. The goal, for example, if you have some experience and you finish this bootcamp, you probably shouldn't have any questions, because this bootcamp is a very simple one for the beginners. And if you understand everything what's covering in this bootcamp, it means you have enough knowledge for the data engineering job, and you can focus more on learning tools like Snowflake, Databricks, Airflow, dbt, and data engineering and data analytics concepts that we're gonna cover in our course. That's it. Thank you, and see you on the next model.